Hi, I'm Eddie from the Alibaba, and today I will talk with Hassan to describe what we want to change in the FRR, especially for the routing domain. So this is not fancy compared to the last one, which is the AI fabric. This is the old world, which I worked for like 17 years in Cisco. So let's look at the history a little bit, like I say, where we are for the routing. So I see the orange also asked the question, like, would it be possible for us to do the routing in the SONiC? I asked the similar question in the 2016 when SONiC started. So I say, you guys don't know the complexity on the network OS. The feedback was given to me is like, say, I'm talking about Tor. There's nothing wrong with that. It's very simple. It is true. So if I back to last year, if someone asked me to say, well, the SONiC would be good for the routing, I would say no, it won't. So then I joined Alibaba last September. Then I realizing they're doing the routing. They're using the Silicon One to do a router. So that surprised me. So I expecting routing that here, SONiC somewhere here. So that's a huge gap in between. So what I should do, because I'm owning that piece right now. So no matter what, being there, done that, we should do it. So that's come to the next one. I come to the TSC. So I give this slide to say, I need to set up the routing working group in the SONiC. The main reason is like, because a lot of people thinking that router is a high scale switch. I would say no. It is not. It's more complicated than the switch. So you just scale the switch doesn't mean that you get a router. So there's a couple of reasons. The one general reason is like, say, the routes. Once we're talking about, because normally switch, you only can say 10K, 20K, maybe like I say the good day you get 100K. Routes, we're talking about the 1 million, 2 million routes. So it's on completely different level of the question. Then this is not a global table. This is on a VPN table. So you have to be more complicated than that. Then since I have 1 million routes, we're talking about the route convergence time. Because if we only have 50K routes, you're just programming for the 5K routes per second, 5K routes per second, you're okay, because it's just 10 seconds. You spend 1 or 2 seconds, not a big deal in the switch. But in the routing, if I have 1 million routes, that's a huge difference. Then the interesting part will be the conversion time. Now you're talking IGB convergence, BGB convergence. That's all the word which Cisco talking about for many, many years. So that's all the enhancement we do. Then the second part is the Linux kernel. Will this really be a good kernel for the router? I'm doubted, because there's no recursive route support at all. And to be good for the recursive route, is a must-have in the routing domain. Otherwise, you have the convergence issues. You cannot always flatten it. Actually, we do see the problem in this year. And the first time we see the problem is from the Alibaba. It's we basically 16 pass over another 16 pass. Then the FR just flattening it to be 256. Then we hit on a bug. Why the 256? Because someone using the UIN8 as a non-pass. So 256 becomes 0 now. So then the whole thing not working. Then a couple weeks later, Microsoft also see the same problem. They crashed. They're even worse than that. So we debug it in the routing working group, then find out, oh, you go way beyond the 256 pass because of clapping. So then the question is like, say, yeah, we could fix it. Otherwise, can we optimizing it to do more better than just flatten it? Can we do the recursive? So that will be another challenge part. So all these, which I give the proposal to the TSC to say, hey, can we do something better for the routing? That's where we set up the routing working group. So for the routing working group, so what we have is we started, here we say we start from the April 2nd, but the real kickoff is on the early May. So April 2nd is Yan Zhao helped me set up the web page. Then I basically send out email to the community to attracting people. So that's why we spend about like 4 weeks before we really kick off. So now we have like say 100, more than 150 people, and we have a daily meeting on that. So the main purpose is just for routing. So that's the main reason for this routing working group. So I will be the chair, and Hassan will be the co-chair, and also Praveen from Cisco and Rita from the Microsoft will be the co-chair. So 4 of us are leading this routing work group. I feel like this is a pretty strong knowledge base to getting routing better, because everybody is working in this domain for a while and have a deep understanding for what the routing should do. So if we cannot deliver something good, I don't think anybody else can do. So that's probably will be the thing. So for today's talk, we focus on the 3 highlight areas. We just talk about what we do for less than half a year. So from now, it's more like 4 or 5 months, right? So see what is the achievement, the momentum we can build, and we want to see what else we want to do in the next. And since we don't want to, because the router, the moment you talk about router, the people will compare and say, hey, Cisco has a whole army there. And you guys don't even just have a couple guys. How do you compete? That's why I don't want to boil the ocean, because the router itself is huge. You have a lot of the things you need to cover, MPLS, VPN, you have ISS, OSPF, a bunch of stuff. So I'm not going in that direction. So I start with the use case. So at this moment, we start with the Alibaba SRv6 VPN use case. So this is something which Shangshuai from my team present in the routing working group. And this is a very typical use case, which actually just a couple talks before, Yongping explained how we were using SRv6 to do the orchestration. So what he did is just say, he treated me as a black box. He just said, you do all these things. So I need to do the heavy lifting to make sure that SRv6 is working in our box. So that's the main thing. So I don't need to go to details for how this works. It's just basically very simple SRv6, just a VPN use case. But we closed a couple of the challenges. So that's where we start and say where those challenges is and how we want to attacking them. So there are a couple of things. One is communication. Right now, the FRR going down the FPM, it will be via the net link. They are debating because I asked, once I talked to the Li Hua from Microsoft to say, hey, I want to start this one. He said, good luck, because people from FRR is mostly NetApp guys. So they love the net link. So if you want to change anything related to the net link, you need to be good luck. So that's something we will start it. Then also the routing loading time, footprint, and also the flapping impact. So we explore those issues, and we want to see how we can solve it. So this one also, like I say, bring another one. It's like I say, if I'm doing this well, was I solving the orange problem? May not be, because what I do is only for this particular use case. So if Orange want to do something like, say, I see hey, they have the PIM, I never want to touch the PIM. So they need to bring out the use case, and we can come up with the community to solving it, but not at this moment. It's not our focus. So this is basically bottom line is that we don't want to boil the ocean. So we want to drive by the use case. So if later on say we have new use cases, I would love to take to the routing working group to discuss it. But the main purpose is that we want to build up the main issues for that. So I quickly go over. This is the summer. We have the summer of the code. It's an Indian program. So I use the summer of code to set up the memory usage enhancement. So I don't need to go to detail. This is the same thing we already done. So all this I have the link in so you can take a look. The thing which I want to talk about today is like I say the pick. I think that for my Cisco friends, probably will laugh at me. Like I say, you did it almost 20 years ago. Now you pretty much do it again. And so yeah, I did it back to 2005 or 2006 for the BG pick. So it's pretty much I do it again because I know this is something we needed for the router. And the other one is like say, why it's important. All the other things I would say, same hardware, but you're organizing your data structure differently. You have different behavior. So that's where I come to the picture to say routing is not that difficult, but I think you put time and effort on it. So this one, basically the idea is that I want to separate the forwarding context with the VPN context. So then that allow me to sharing the forwarding context so I can make the change accordingly. So that's the main idea for the BGP. So that's pretty much I have. Then I will let Hassan to start your portion.
Yeah, thank you. Thanks, Eddie. So BGP route loading time / route convergence was one of the first few topics we took up in the routing work group. As Eddie is saying that, the routing is still in its infancy. Broadcom added EVPN a couple of years ago. Specifically on Trident 4 platforms, we were trying to scale up to 1 million route. And what we were seeing was it takes like 6 to 8 minutes to install all of these routes in the hardware. And this is just one SONiC device connected to the traffic generator. If you have a bigger network where the routes are coming from multiple sources, it takes even longer. And many times, the network does not even stabilize. And there were memory-related issues, not all the convergence. So what you see here is the typical, is the workflow of a route in the SONiC subsystem, where the route actually is coming from the BGP, gives it to Zebra, to FPM SINCD, to AppDB, and ArcAgent, right? And then again, into the Redis and SINCD, and then, so it takes like 6 hops before it gets on the hardware. And not only us, I mean, team at Alibaba was also actually facing the similar challenges. In fact, somebody was from the audience who raised similar concern that, how much are you scaling? 1.6 million, can you even do it in SONiC, right? So yeah, this is the fundamental of the routing. And the question is, 8 minutes is too long. How can we even optimize it? So we started looking at each of these hops in the middle and then see that, where exactly the sluggishness is being caused. And what we see is, basically we started with, say, FRR, because, that is the entry point. We just cut it off from the FPM SINCD and wanted to see that how it behaves. And pretty amazing, FRR could install 1 million routes in the hardware in less than 30 seconds. And so did the SI. I mean, if you're just making the SI calls, it does not take 30 seconds even, actually, you can see all of the routes in the hardware. Then the next suspicion was in the Redis, because everybody thinks that there's a database and it might be slowing down the things. And we already have the Redis benchmarking tools available. And if you run those benchmarking tools, you see like 35K route, 35K operations per second, which is pretty good. If one operation is one route, then you end up actually having 35K routes per second speed, which is pretty good. So then the focus was that, okay, let's go to the next step, that what happened. I'm not putting the right numbers here, because depending on the platform and the CPU horsepower, actually things may vary. But when you look at, say, FPM SINCD, ArcAgent, and SINCD, you see that majority of the sluggishness is being caused in the ArcAgent. And FPM SINCD and SINCD are also actually on the same line. I mean, they are the ones which are actually not doing their job as best to let the route go. So we went through a series of analysis and the gprof profiling, flame graph, and see that what exactly is happening and why this is why these components are causing sluggishness. It turned out that there are quite a few fundamental things which are going on. One is majority of these components are sequential in nature. When they are doing a pop operation from the Redis, they are just doing the pop. They're waiting for the IO to complete, and then once the route comes in, they do the process, and then again writes into the Redis. And not only that, the pop operation, which the ArcAgent is doing, it happens in a Lua script. And every route entry which is being popped from the AppDB results into 3 Redis operations. So even though it is like 30K, 35K route, Redis pop Redis operations, but you're just cutting down by 3 because one route is resulting into 3 Redis pop operations. And also, if you see, there's a synchronous side. The org agent, when it sends route update, bulk route update to syncd, it is synchronously waiting for the ACK to come back. And that is also adding to the delay because it's just waiting. It's not doing anything else. So together between Alibaba and Broadcom, we went through a series of bringing in optimizations, starting from FPM syncd to org agent and to syncd. We optimized FPM syncd by tuning the buffers and seeing that how much buffer can be used to actually write as much as possible in the Redis. Org agent, we added 2 new pthreads, one for just doing the pop from the app.db, and another one for asynchronously waiting for the ACK, which is coming from the syncd. And the Redis Lua script was modified to convert the 3 operations into 1. Similar optimization were done in the syncd, where the team added a new pthread, which is just waiting for while the syncd is making the cycles, the other pthread is waiting and dequeuing the route updates coming from the Redis DB, the side Redis. With all these optimization in place, you could easily bump up the speed by 2 to 3 times. And we have the HLD out there. It will be reviewed this Friday at Alibaba's office, 1 p.m., right? So yeah, feel free to join. Yeah, that's pretty much, actually. Call to action. I would like to say that this is, Routing Workgroup is a great platform which is bridging the gap between SONiC and FRR communities. Before the Routing Workgroup was there were quite a few things which are in isolation between SONiC and FRR, and it was not easy to actually get things through. And we have leads and maintainers joining from both of the work groups there. The meeting happened at 5:30 p.m. PST every Thursday. Quite a few things get discussed, and it's very easy to come up with this viable solution because folks from both of the sides are present. So please join the work group. Another thing we want to bring in here is that we need cross-collaboration between FRR, SONiC, and SCI. The reason is some of these fundamental challenges, they cannot be solved in isolation in SONiC. Instead of putting the hacks and patches within SONiC, it needs a full vertical, starting from the FRR to the SONiC to the SCI. And without collaboration, this is not possible. I think the Alibaba is a good example where they brought in the interns, the college interns. And this can be a great platform for the college students, who want to learn about routing, get comfortable with what we are doing, contribute to the open source, and gain the experience. So yeah, that's pretty much. I mean, do you want to add anything?
No.
Okay.
Thanks.
Yeah.
Thank you.
Thanks.